Sometimes, even though we have the option to use the natural logarithm and the common logarithm, one of the two is going to be a better option. Let's see with this example. If we have 8 and we have e raised to the power of 2x is equal to 20, and we want to find the value of x. At first, or the first step is to isolate the exponential expression. So this 8 needs to go. That means that we need to divide everything by 8. And we're going to end up with the exponential equation looking like e raised to the power of 2x is equal to 20 over 8. And then we might want to simplify the fraction. So if we get half, it's going to be 10 over 4. Half of that is going to be 5 over 2. So this is equal to 5 over 2. Now that we know how the equation is going to end up looking like, we can get or choose the natural logarithm or the common logarithm. Just remember that this logarithm is a base e logarithmic expression. So that would be a better choice because this is an exponential with the same base. So I'm going to pick that one, and I'm going to write the natural logarithm of the exponential e raised to the power of 2x. And I'm going to get the natural logarithm of 5/2. And that will allow me to use this law, the one that we have previously stated, that if we have any logarithm of a raised to the power of c, that can be expressed as c multiplying the logarithm base n of a. So we're going to use that law in order to have 2x times the natural logarithm of e and the natural logarithm of 5 over 2. If you recall, we can evaluate logarithms, and if you have the natural logarithm of e, that is going to be equal to 1, because you're basically saying that logarithm base e of e raised to the power of 1 will get you e raised to the power of 1. So the answer is 1. So this whole thing will become a 1, something that wouldn't be an option if you went for the common logarithm. This would end up being the common logarithm of e, and you would be stuck with that on your exact answer. So this will end up as a 1. This will make things easier for us because the equation is going to end up as 2x being equal to the natural logarithm of 5 over 2. And the exact answer is going to be x is equal to the natural logarithm of 5 over 2, everything divided by 2. So let's reveal the whole thing. So we get x being equal to the natural logarithm of 5 over 2, everything divided by 2, and the decimal approximation would be 0.458. This decimal approximation would be obtained if you use the common logarithm, but the exact answer would look something like this. The common logarithm of 5 over 2 divided by 2 times the common logarithm of e. So why use this additional logarithm if we can have a simpler version of the answer? So the same is going to happen when you have a base 10 exponential, like this one right here. If you have a base 10 exponential, you could also use the natural logarithm in order to solve this one. You could write the natural logarithm of 10 raised to the power of x and the natural logarithm of 25. But if you solve for x, you're going to have x times the natural logarithm of 10 is equal to the natural logarithm of 25. and x will be equal to the natural logarithm of 25 divided by the natural logarithm of 10. And if you notice, if you use the other version of the answer, meaning using the common logarithm all the way through, instead of having the natural logarithm of 25 divided by the natural logarithm of 10, you're going to have the common logarithm of 25 divided by the common logarithm of 10. And if you solve this or evaluate that logarithm, it's going to be 1. So the final answer will be the common logarithm of 25. And even if you want to go a bit further, you could rewrite this as the common logarithm of 5 squared. And then we can bring down that exponent and have it as 2 times the common logarithm of 5. That's just getting a little fancy for the exact answer. So both will be correct. And the decimal approximation is just going to your calculator and finding the answer. But the only one that you could substitute here and get exactly 25 would be either of those two options.